What if you could take a concept like Boyle's law, which we teach in chemistry classrooms? Boyle's law says that the pressure of a gas is inversely proportional to its volume at constant temperature. What if you take that concept and take a chemistry teacher and a physics teacher and a math teacher and an engineering teacher and a computer science teacher, and we all have a conversation about Boyle's law, and we build an apparatus to test Boyle's law, and we collect data about Boyle's law, and we study the details in a holistic approach, looking at different branches of STEM, looking at the same thing. Boyle's law is taught in chemistry, but it could be discussed in physics, but it needs mathematics to work out, right? So we need to start encouraging our students to think about this. This would be success. Imagine a student is in your physics class trying to do a problem, and they are stuck. And then they say, I need to go talk to the math professor on the other side of campus because I need a mathematical model that they might be able to provide me. See, when students start thinking like that with that interdisciplinary approach, we have success. Because we don't want them to be in silos. That's not how the greatest scientists did it. Isaac Newton, we say the co-inventor of calculus with Gottfried Leibniz, he did a great job of what he did in understanding gravity and understanding why planets behave the way they behave and connecting it to calculus, right? That's what Newton did. But gravity is discussed in physics class, calculus is discussed in math class. Newton did both. That's the model I want to encourage young people to have. Knowledge that is based on truth and that is valid will not contradict with another piece from another field of study, quote unquote. So I look forward to that math student who's going to say, I need more practice in physics to apply the math I'm learning, or in chemistry to apply the math I'm learning. That integrated knowledge will help a lot. So stay tuned as we discuss concepts holistically in chemistry and physics and mathematics and engineering and computer science, so students see that what they're learning is in action. It's working. It's being used for something, and it's not just some abstract idea. Now, are they abstract math concepts? Yes, they are. And my excuse for doing some of those is that they're beautiful. Even if they have no application, they're beautiful. But also, there were certain things that had no application in the 1700s, and today, what do we do with them, right? The 17 and 1800s gave us things like the work of Joseph Fourier. It gave us things like work of Daniel Bernoulli in certain fields of fluid mechanics, fluid dynamics. So therefore, we need to encourage students to persevere. Persevere and keep working hard, even if you don't see the point in front of you. Many of these students play sports, and the question is, do they see the applications of the sports that they're playing outside of the arena in which they play? For example, when you play volleyball, are you using the volleyball itself, quote unquote, skills outside of the volleyball court? Not necessarily. Or tennis. Do you go anywhere else and you're swinging a racket? Not really. So therefore, you don't play the sport simply because it has some application outside of the time you play the sport. You play the sport because there's an enjoyment you have in the sport itself. And there's some byproducts of that enjoyment that can help you to flourish in life. Like teamwork in volleyball, like teamwork in football and soccer. And I mean the real football, not American football. But anyways, I'm kidding. I'm from Nigeria, and so we call it football. But the point is, let's encourage young people to persevere, to give their best, even when they don't see the reward in front of them. Math can be a character building subject. It can build character. It can help people to flourish as they were created to be, or to flourish. I look forward to sharing more, but this is just one example of the integrated knowledge that needs to happen in this day and age we live in. Okay, I'm excited. I hope you are too. Please feel free to subscribe, like, and share this video with your friends as we explore what it is like to raise the next generation of scientists, mathematicians, and thinkers who also know the history and philosophy of science, logic, and theology. Just like Isaac Newton, James Clerk Maxwell, Robert Boyle. Interesting. You can study Robert Boyle and his faith as well. Very interesting guy. Take care and have a blessed day. See you in the next video as we continue our journey from counting to calculus and a historical framework and also an integrated framework. Have a blessed day.